So this video is going to be about solving equations, and we're going to be looking at our third type, which are compound inequalities. Now, hopefully you've already watched the linear inequalities because we're going to use that information to build on and solve some compound inequalities. We're going to solve those inequalities, and we're going to be graphing them on a number line to show the solution set. Now, compound inequality is like a linear inequality, except that we have two of them together. So basically what you're doing with a compound is you're taking two linear inequalities and putting them into one compound inequality, which you then solve each side separately. The graph will be all the solutions that satisfy both of those inequalities, okay? So this is a compound inequality. It's compound because I have two inequality signs. So this is saying that x is all of the numbers that are greater than -1 as well as less than 2. So let's think about what kind of fits that. Well, 0 is greater than -1 and less than 2. 1 is greater than -1 and less than 2. 4 is greater than -1, but it's not less than 2. So 4 would not be included. It'd be all the numbers greater than -1 up to 2. So let's graph this and we'll kind of show. So we have, I'm going to put 0 in the middle, and then I've got 1, 2, 3, 4. And then 1, 2, 3, -4. Okay? So I'm going to graph each of these separately. If we were to graph just x is greater than -1, that would be an open circle at -1, and it would be pointing all the way to the right, all numbers greater than -1. And then if I graph x is less than 2, that's an open circle at 2, pointing to the left to cover all of the numbers that are less than 2. Well, because this is a compound, I want to know where do these cross, because I need the numbers that are both. Well, that would be the numbers from here to here in this middle section between 1 and 2. So let me erase this because this is kind of a mess, and I'll show you what it actually looks like when we graph it. So when we graph this, we're going to put an open circle at 1, an open circle at 2, and we're going to connect them. And I kind of like to think of it, x is between -1 and 2. So x is all the numbers between the circle for -1 and the circle for 2. Let's try another one. This is an or statement. So the last one was considered an and statement. This is an or statement. So we're going to talk about all the numbers that are either less than -2 or greater than 1. So let's make that number line again. 1, 2, 3, 4. 1, 2, 3, -4. Okay. Let's start with the x is less than -2. So I'm going to have a closed circle at -2, pointing left because we're talking about all the numbers that are less than -2. And then for the second part, I'm going to have an open circle at 1, and I'm going right because we're talking about all the numbers that are greater than 1. Notice I have two pieces here. This time, the only thing that doesn't work are the numbers between -2 and 1. So if you can think about it this way, an and statement where x is in the middle, the arrows are coming together. An or statement, the arrows are going apart. If that kind of helps, you know kind of which one to graph and how to look at it. So let's try some solving here, okay? So we've got this compound inequality. We're going to solve it. So what we're going to do is first we're going to look at the left side, which is -4 is less than 6x minus 10. That's the first inequality. We're going to solve this one up. So we're going to add 10. We're going to divide by 6. And we get 1 is less than x. Then we're going to take the other side and we're going to solve here. So we're going to say 6x minus 10 is less than or equal to 14. We're going to add 10 and divide by 6. And we get x is less than or equal to 4. Now I have a compound inequality, and I'm going to put those back together. So I'm just going to kind of join them together with x in the middle. So I have x is greater than 1 and x is less than or equal to 4. Now I can graph this on a number line. I'm just going to start with 0 on the left here. 1, 2, 3, 4, 5. So I would have an open circle at 1, a closed circle at 4, and this is an and, so I'm going to connect between them to create my inequality graph on a number line here, okay? So solving is pretty easy. You're just splitting it into two parts at the signs and solving each, I'm not going to say half because that's not right, but each side. And then getting your compound inequality and graphing it. Let's try another one. Now the ors are nice because they're already split, and so you're just solving each one on its own. So if we take 3x plus 5 is less than or equal to 11, and we subtract 5 and divide by 3, we get x is less than or equal to 2. Or, and then I'm going to come over here and I'm going to solve. So I'm going to take 5x minus 7 is greater than or equal to 23. I'm going to add 7, and I'm going to divide by 5, and I get x is greater than or equal to 6. So now I have a compound inequality, and this one is an or statement. Remember, an or statement means that they're going to go away from each other when I'm graphing. So let me get this number line. I'm going to put 0 to the left again because I've got, let's see, 1, 2, 3, 4, 6, 7, 8. And I'm going to make a closed circle at 2 and point my arrow to the left because we're talking about numbers less than 2. And then I'm going to make a closed circle at 6. And I'm going to point my arrow to the right because we're talking about all the numbers greater than 6. Now, let me back up a second. How did I know that those were closed circles again? Because they both had the equal sign. Oh, that's a terrible arrow, sorry. Underneath the inequality. That's how I know they're closed circles. And then how do I know that they're pointing opposite directions? Because this is an or. An or always means that the arrows are pointing away from each other, okay? Let's try another one. This would be a good time. Why don't you pause the video and solve this and see what you get. So one of the things that I like to do with the ands is I kind of like to solve them simultaneously. And you can do this if it makes sense to you. And if it doesn't, that's fine. Separate them out, okay? So I see that I need to add 3. So I'm just going to add 3 to both sides. And I get 5 is less than or equal to x is less than 9. And that's done. That's pretty easy. If you split it up into the two parts like I showed you before, you would get exactly the same thing and put it back together. I just kind of like the shortcuts, so I like to do it a little quicker if I can. Let's graph this on a number line. So I'm going to start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to have an open circle at 9 and a closed circle at 5. And again, remember that the inequality signs are telling me open and closed. And then because this is an and, where x is in the middle, I'm just going to connect them. Whoops. There we go. Okay. One more or. So this one's going to be split. Remember that or means it's going in opposite directions. So I'm going to solve each one separately. So here I'm going to add the 3, and negative 4 plus 3 is negative 1. So then I'm going to divide by 2, and x is less than or equal to negative 1/2. Or, and then I'm going to go do the other side. So I'm going to subtract the 1, and 4 minus 1 is 3. So I have 3x is greater than or equal to 3, which means that x is greater than or equal to 1 when I divide. I'm going to graph this on a number line. Now, what do I do with that fraction? Well, here's the thing. This is my number line. I can number it however I want to. So what if I do 0, and then I do hash marks for the halves? So I've got 0, and then a half, and then a 1, and then a half, and then a 2, and then a half, and then a 3. And I can do that on the other side too. So I've got a hash mark at negative half and then negative 1. Notice I made the hash marks a little smaller than the whole number hash marks. So that's, again, it's your number line. You can number it or notate it however you want to. So I'm going to put a closed circle at negative 1/2. And I'm going to draw my arrow to the left because I'm talking about numbers that are less than that. And then I'm going to put another closed circle at 1 and draw an arrow to the right because I'm talking about numbers that are greater than or equal to 1. Hopefully this is making sense for you. Hopefully you can solve compound inequalities, and I probably should have also included that you can graph them on a number line because that is important as well. You need to be able to show the solution set of a compound inequality by graphing it on the number line. Have fun graphing and solving those inequalities.